Hey everyone, this is James and Louisa, and our lab 7 is eggs and baking, pie crusts and pastries specifically. So, just to introduce, we'll start with the saying. If you've ever heard this saying before, it's cooking is an art and baking is a science. Um, I don't know if you've ever heard that, but it's in reference to the fact that when you're cooking a meal, you can usually get away with not measuring, or just basically adding according to your preference. So this is when cooking. But when baking, if you don't use exact measurements and you just kind of go off of like, oh, I like salt, then you'll probably end up with something that is not perfect and may not even be edible. It might be just it might fall apart. It might just not even have any of the texture that you needed to have. So I added this little picture of one of those nailed it type failures where somebody tried to create a baked good like a little cake and it was just turned into a total disaster. And obviously these nailed it things were sarcastic when that was happening, when those were popular. But it really plays into this whole idea of cooking being, an art, and you can kind of make it go however you want, but baking really needs to be pretty exact, or you will have some of the problems that we come across in this lab, which Louisa will explain to you right now.
So, for our problems, first, let's talk about burnt edges. Have you ever baked a pie and noticed the crust edges get too dark before the pie is actually fully cooked? This usually happens because the edges bake faster than the rest of the pie. And this is usually due to uneven heat distribution or a thin crust on the edges. So, how to fix this? To fix it, you can cover the edges with aluminum foil or use a pie shield to protect them during baking. Another option is lowering the oven temperature slightly and baking the pie for a longer time. Or also you can make the crust a little bit thicker. Next up, we have a soggy bottom. So this happens when moisture from the filling seeps into the crust, leaving it all wet and mushy. And for the solution, you can blind bake your crust before adding to the filling, and you can also use a thicker crust or add a layer of breadcrumbs, cornmeal, or crushed crackers to absorb the moisture. These small changes can make a huge difference in achieving a crisp, firm crust. Now, we're going to talk about air pockets, large air pockets, and bubbles. These bubbles usually form when the air is trapped in the dough expands during baking. So to prevent this, you can dunk the crust by poking it with a fork before baking. Also, refrigerating the dough longer, it helps reduce the air pockets, and this will ensure a smooth, even crust that actually looks as good as it tastes. And then for our final problem, we have a leaky pie filling. And this usually happens when the filling doesn't thicken properly or the fruit releases too much liquid. So to fix this, you can use thickening agents like cornstarch, tapioca, or flour. But it is also important to let the pie cool completely before slicing it so the filling can actually set. And with baking and with pies, patience really pays off in this process, right? A fully cooled pie holds together really beautiful when it is sliced.
So those are our specific problems, and some of the key ingredients that help these baked goods maintain structure. Um, I'm going to elaborate on now by answering a few of the questions that were posed to us. So, how do these key ingredients play a role or contribute to tenderness and to volume? So, the two ingredients that we chose to elaborate on here were butter and shortening. And these are types of fats, and they're going to contribute to pie crust and or pastry flakiness, and specifically, they're going to increase. So, the more fat that you have from butter or shortening, the more pie crust or pastry flakiness you're going to have. Obviously, to a certain point, you'll increase up to like that threshold, in which you'd just be dealing with way too much. But yeah, butter and shortening are going to contribute to flakiness. And then your acids that you could possibly add, things like vinegar or lemon juice, will prevent gluten formation, which is going to end up creating a more tender texture to the final product. And then with emulsifying agents, they're going to contribute to tenderness and volume as well, by just the emulsifiers are going to be creating a mixture in terms of the mixing of the different materials that you're putting into your final product. So the way the emulsifiers actually work is they're taking the lipids and the water molecules. Lipids are hydrophobic, water molecules are hydrophilic, and they don't want to mix. And the emulsifier is going to take the hydrophilic on one end, the hydrophobic on the other end, and it's going to keep them next to each other, as opposed to just splitting apart and having two totally different like layers. Each one, the emulsifier is going to grab a hydrophobic oil, hydrophilic water, and it's going to keep those molecules next to each other. And each emulsifying agent is going to do that. So it's going to keep these ingredients combined within this product. So it's going to give the final baked good an even distribution of ingredients, which will then give an even texture throughout that entire product, which will positively contribute to tenderness and volume. And some common emulsifiers in pie and pastry baking are things like lecithin, which you can find in soy, but then also eggs. Egg white protein is a common emulsifier. And then proteins in general, like whey, soy, pea protein, they could all be added to emulsify the ingredients. So the next question was, what do different types of flour do for different types of recipes, and which are appropriate for some but not for others? So there are quite a few different types of flours that can be used. And all-purpose flour is a type of flour that's going to create a final product that is flakier than one that is made with pastry flour. And there are a lot of other flours that could be used for other cooking purposes, but they're not as useful in baking. They lack the elastic and cohesive qualities that are needed for many baked goods. Whole wheat flour can be used. It is wheat. It's going to retain some of those characteristics, those elastic and cohesive characteristics that wheat flour would have, but you may need some modifications to the recipe. For example, whole wheat flour is going to absorb a lot more water, so you may need to increase the amount of wet ingredients that you're using in the recipe. You will be getting, like I said, a lot of those positive ingredients still from the wheat, but you may also be getting some extra health benefits, as whole wheat flour does offer some extra health benefits. So as long as you can modify accordingly and still get that texture that you want, you should probably be okay with a whole wheat flour. And then the next two have some ingredients added to them, which could make them more convenient or easier to use, but that then may not be appropriate for certain situations. For example, self-rising flour already contains leavening agents and salt, and that would not be appropriate for pastries that have yeast in them, because yeast is already going to provide leavening. And the instantized flour is is going to be appropriate for sauces and gravies, in that it's purposefully going to become very, very thick. And that is not something that you would want for baking in general at all. Really, the main use you would use for that is for something that you want to become super thick, and that's just not what you want in baking. So then the last question was, how does steam contribute to the flakiness of a pastry? And then what are other forms of leavening that could be used in different baked goods? So steam is a far more effective leavening agent than air, which is something that I didn't know before any of this. So I found that to be really interesting. And the steam is created within the pastry when heat is applied. There's water inside of the recipe that you made, and that steam is created inside of the pastry. And then as that steam is created and it's rising, it's going to force the layers of the dough to separate, which is where that flakiness is going to come from. So there are quite a few different types of leavening agents, and we've categorized them here to the biological leavening agents, which would be things like yeast, and then chemical agents. such as baking soda. And when they are activated, like yeast, or when they are mixed with other ingredients, acidic ingredients, when an acid mixed with an alkaline, um, both of those, when they're either activated or mixed, they are going to create CO2. And as that CO2 rises, that is going to cause the dough to rise, which will cause the layers to separate and then increase that flakiness. So the creation of CO2, whether it's from a biological agent like yeast or a chemical agent like baking soda, is going to cause those layers to separate, rise, and then increase the flakiness of the final product.
So to wrap things up, mastering pie crust and pastry requires actually paying attention to issues like we mentioned, the burnt edges, the soggy bottoms, the air pockets, and the leaky fillings. But also, making small changes within the techniques like foil shielding, blind baking, and using thickening agents can make actually a huge difference um, to the final product. Also, key ingredients like butter ensure that flakiness, acids, ensure flakiness, I'm sorry. Also, acids enhance tenderness and emulsifiers and flour selection. They do play a crucial role in the texture. Also, steam and leavening agents contribute to the flakiness and the volume of the pie crust and the pastries. And they actually ensure consistent and quality results. Thank you.